Okay, this is for MA031, and it's the ABC answers that were mentioned in class on Friday. And so for question number one, your answer should be 1. For question number two, your answer should be 3z plus 2 divided by z times the quantity z minus 1. Now, if you wanted to distribute the z times the z minus 1, that's fine. You can do that. Number three, the only answer is 1. The only solution is 1. Number four, a quadratic equation that you factor and then set each of your factors equal to 0 should get solutions of -4 and -2. And of course, the order isn't important there, but you do need to show both answers. Number five is the absolute value inequality. And in this situation, we have negative infinity to -2 inclusive, demonstrated by the square bracket, union with the interval from 6 inclusive to plus infinity. Okay. Number six, your answer should have been y equals -1/3 x plus 5/3. It was asked for that slope intercept form. Okay. Um, when you factored question number seven, maybe by AC method, um, you should have had in some order the quantity 3y plus 2 and the quantity 2y minus 3. Right? And then question number eight is the first of the trig questions. And of course, tangent of 5 pi over 6 would be a second quadrant angle. So your answers are negative 1 over the square root of 3. That's one possible answer. Or you might have had negative square root of 3 over 3. Okay. Um, either one would be acceptable. You don't have to have them both, of course. Right? So now if we move ahead, um, to the next exercises. Start with number 9 here. We have tangent 3 pi over 2, and you should have found that to be undefined. Okay, that should have been undefined. Remember, tangent of 90 degrees doesn't exist, and so this would be 90 degrees in the third quadrant or fourth quadrant, and so it's an undefined situation. Right? Number 10, more trig. A couple ways you can do this. You can set it up using right triangle trigonometry and do a tangent ratio. Or other people might have identified the pi over 6 as being 30 degrees, and so they might have worked with the 30, 60, 90 triangle and worked with those ratios and set the problem up like that. Um, Probably the best answer is square root of 3. It's probably the best answer. Um, but it would be acceptable. I believe they would allow 3 over the square root of 3, even though you can make the argument that's not simplest form. Uh, one of those should have been your solution. Question number 11 is the trig. Find a value with one of the sides missing, and here they're looking for cosine. Cosine, of course, is adjacent over hypotenuse, and for the angle that they provided here, um, that's going to require you to do a Pythagorean theorem, and you should have figured out the missing side was square root of 15, and so the cosine ratio would have been square root of 15 over the hypotenuse, which is 4. So that should have been your answer there. Number 12 is a graphing question, and they're asking you to graph y equals tan x from negative pi radians to pi radians. So, as we've discussed, you want to use the space, is probably the best advice. So, there's pi, there's negative pi. Of course, in between here, we're going to have negative pi over 2, and we're going to have pi over 2. So, you kind of want to set those up. And then knowing the tangent ratio does not exist, as we've already mentioned, at 90 degrees, you're going to get an asymptote in there, right? And likewise, you'd have an asymptote at negative 90 degrees. So you want to show those. It says you should show the asymptotes. right? And then 90 degrees in the first, from 0 to 90 degrees in the first quadrant, tangent graph looks like that. And again, becomes asymptotical with the line x equals pi over 2. As you move into the second quadrant, the tangent is negative. It rises up as it approaches 180 degrees, and at 180 degrees, it has a value of 0. Then, uh, third quadrant, of course, tangent is positive, and so this is going to represent that from negative 180 to negative 90, from negative pi radians to negative pi over 2 radians. That's representative of what's normally the third quadrant, right? And then fourth quadrant, of course, again, tangent's negative. We go from negative pi over 2 back to 0, and it connects in like that. So should have had a graph something to this effect. Um, if you want to identify the asymptote, it's x equals, right, because it's a vertical line, pi over 2, and this one is negative pi over 2. So those are your two asymptotes. Um, Question number 13 is the exponent question, the first of a couple of exponent questions. And of course, you want to know your power rules, your exponent rules very well. And so when you did this one, your final answer should have been x to the 8th, right? Because you raise the power to the power, you get x to the 10th divided by x squared. When you divide two numbers with a common base, you subtract the exponents. So that's how we're getting x to the 8th, right? Um, so now if we move ahead to the next section, and so we'll slide up to just a little further if we can. We can get the whole thing in. Slide up to number 14, and your answer there, when you get um, positive exponents, um, couple that would have been acceptable could have had 1 over x to the 2/3 y to the first power. And again, raising the power to a power on a multiplied uh, pair, you just multiply each exponent. And of course, that would make them negative. X to the negative 2/3 would have been your first step, right? And y to the negative 1. Well, we have to remove the negative exponent, so we use the 1 over rule. So that would have been an acceptable answer. Uh, or, remember, just to emphasize this, that 2/3 power means cube root, and the 2 is your power. So cube root of x squared times y would have also been an acceptable answer. All right. 15, we have a variable exponent, and this can be done by a common base technique, and the answer should have been negative 3/4 for x. Negative 3/4. And what you do there is 16, of course, is 2 to the 4th. That's pretty obvious. You raise that to the x power. And when you think exponentially about 8, you know that 8 is 2 to the 3rd. Well, from there, we're going to sort of use that 1 over rule in reverse. We're actually going to move this to the exponent, or to the numerator rather, and make it negative. So we get 2 to the 4x equals 2 to the minus 3 power, right? So moving that term to the exponent does indeed make that exponent, moving that to the numerator does indeed make that exponent negative. And then you've got your common base, and so you set the things equal, and that's where the negative 4/3 is coming from. Number 16 has to be done by way of logs, and your solution could have been one of a couple things. You could have had log 5 divided by 2 log 3, okay, and plus 1/2. Okay, so there's your solution for x. Or you could have had this thing written as 1/2 log base 3 of 5 plus 1/2. And there are other variations you might have had because they both have a 1/2. You could have the 1/2 out in front or something like that. So those are the two most likely answers, I think. Um, 17 and 18, moving into the graphing questions. Of course, this was pretty straightforward. It was all set up. You didn't have to do any work to solve it for y. What we do want to point out here is getting a good rendering, getting a good workable drawing. Your y-intercept is -1, so I would probably identify that down here as being -1. And since your slope, right, your slope in here is a 1, then you're going to rise 1, run 1. So if that's -1, then +1 would sit maybe in there. And so your line should have looked something like this, right? Continues. And you do want to identify the slope because they ask you to do that as a 1. We've identified our y-intercept. Okay. Of course, the vertex comment is with regard to parabolas and that sort of thing. You should identify this point as a 1. All right. And that's pretty much it. Pretty much all there is to that question. Now, 18, this ends up being a parabola. And the axis of symmetry turns out to be the y-axis. And so I put a -2 in here. That's where my vertex is going to be. And then as I would sketch this out, x-axis, y-axis, this would be -1, this would be -2, this would be 1, this would be 2. And when you find the zeros, when you find the roots of the equation, when you find the x-intercepts, you should have ended up getting a negative square root of 2 and a positive square root of 2. So you should actually identify those as well, right? This is negative square root of 2, and this is positive square root of 2. Okay. Um, and the turning point is pretty well identified. If you wanted to list it as 0, -2, you certainly could. All right, but that's a good workable diagram. Uh, Paying attention, doing the prep work for it, finding the intercepts and plotting accordingly and planning the space so you get a good diagram. Right. The area of a rectangle, this was pretty easy. Uh, as these questions go, the questions 19 and 20, it is 9 meters times 3 meters. You don't want to forget your units, so it's 27 meters squared. Right? Or you could write square meters, I suppose, for your units. Now the volume of a sphere, um, again, formulas aren't provided typically on exams. They might be on occasion. Uh, but the formula for the volume of a sphere is 4/3 pi r cubed. Okay, and with an identified radius of 5. You want to always be careful in this question. Sometimes they'll give you something that's related to the item you need in the formula, but it might not be the exact thing. For example, they could have told you that the diameter was 10, so then you would have had to adjust for your formula, right? So when you get all done here, um, you're going to have 4/3 times pi times 5 cubed, right? There's going to be a 5 going there. And 5 cubed, of course, becomes 125. And then you probably multiply the 4 and the 125. So your final answer probably best put as 500 thirds pi. And these are feet. And it is volume. So those are cubic units. Okay. So there's the answers to all 20 of them. Um, Hope you were successful. Hope you're getting the hang of these ABCs and discuss them. Spend some time to find out what went wrong, if you made mistakes, and we'll see you in class on Monday.